A genie appears and asks you to sort this circle. What do you do? Let's do some sorting visualization today. You've all seen sorting visualizations before, haven't you? They generally tend to look like this. You will have a canvas or a window or a frame or something of that sort, and you will have a bunch of vertical bars that are shuffled throughout this canvas. Now the sorting algorithm will run through this and it will sort these bars or these lines to their specific height. In the end, they'll probably end up looking like this. Yes. Now I wanted to do something similar, have a sorting visualization, but use the hue circle to perform visualizations. Okay, to start doing this, we'll have to first draw a hue circle and then shuffle the hue colors around this circle so that they appear randomized. So let's get started with that. We'll start with some setup. I'll declare an array called values array. This is going to be an integer array containing values from 0 to 360. This is the array that we are going to sort. Next, we'll capture the load event of the window and we'll initialize the canvas and the 2D context as we always do. I'll initialize some context features such as line width, the design of the line, and the font. I also want to calculate the center of the canvas and also the radius of the hue circle. Its purpose will become apparent in a short while. Next, I'll create a simple loop of 360 and push those integers into our values array. Finally, I'll call a function called drawHueCircle, which we will define in just a bit. The drawHueCircle function first starts by clearing the canvas with the black color. I'll declare our angle in radians in a variable called radians, of course, and also how much to increment our angle by in a variable called radianadd. Remember that a circle is always 2 pi. Which is why our angle increment is calculated as 2 pi divided by the number of values in our array, which is 360. In our loop, we'll calculate the x and y locations using the maths cos and sine functions like so, and simply draw a line from the center of that circle to the calculated x and y locations. We'll increment the angle at the end, of course. Finally, I'll call the request animation frame, thus making our drawHueCircle into a loop function. We'll also create a function called shuffle, whose job is to shuffle a given array randomly. We'll create two variables, a current index, which starts from the end of the array, and a random index. We'll loop through the array in the reverse order and we'll pick a random index first. All we have to do now is swap the value of the current index with the value of the random index. This ensures that the array would be randomly shuffled. Now, once we are done, we'll simply return the array. Check it out. When I load the HTML file, I get this very beautiful hue circle as intended. Now, let me call the shuffle function and pass the values array here. Now, this will, of course, completely shuffle it, and you can see that the circle is now completely randomized and it's shuffled. All right. So it's not just random colors. Remember that this is shuffled, which means they've just sort of, switched places. Okay. That being said, we now have to start to sort this array. Let's start with our favorite algorithm, the bubble sort algorithm. I said favorite algorithm when I meant that this is the easiest one to implement. You probably know how this already works, but in case you don't, this is how the bubble sort algorithm will work. We'll start with an array that is completely randomized. An index keeps track of where we are in the sorting process. All right, we always start the index with 0. We'll compare the item at the index with the item at the next index. If the item in the current index is larger than the item of the next index, we'll simply swap it so that the larger number ends up on the right-hand side. All we have to do is now do this process over and over again until the array is started or it is sorted. Now let's run through this and let's see how that goes, right? So 5 is compared with 1. So 5 now ends up on the right-hand side. Next, the index has now moved to the first element. So that is checked with the next one. 5 is obviously larger, so it ends up on the next one. 5 is then, the index has now moved to the second position. 5 is now larger than 3, so 5 ends up once again on the right-hand side. Now when this is compared, what will happen is that 5 is not larger than 7. So 5 will remain where it is, but the index has moved. So 7 and 4 are compared and 7 is now pushed to the right. The same process happens and 7 now ends up at the very end. Now in the next iteration, this process is started all over again, but it will not go to the very last element. It will end with the penultimate element of this array. So once again, 1 and 2 are compared and nothing happens. 2 and 3 are compared, nothing happens. 3 and 5 are compared, nothing happens. But 4 and 5 are compared, and what will happen is that 4 and 5 will swap places, and therefore at the very end you will see that the array is sorted. Now this is a very simple process to look at, but to implement it, I think it's even more simpler. Let's implement this in code and let's see how that goes. Before I begin writing the bubble sort function, I'm going to be creating a class called sort prime. This class will be the parent class of all of the sorting algorithms that I'll implement. The constructor declares some variables that we will be using. They are an index variable, a loop count, a swap count, and variables to keep track of the time elapsed. I also have a variable that determines if the sorting is done. I have functions also declared called the init sort, the name of the sort algorithm, and also a do sort function that will be our main sorting function. We'll create a class called bubble sort extending from the sort prime class. We'll implement the do sort that loops through the values array and swaps the elements at the current index and the element at the next index if the value at the current index is greater than the value at the next index. Finally, we'll increment the main index variable and check if the sorting is done. We'll also call the do sort after a set timeout delay. The timeout delay is a global variable that I have set to 25 milliseconds. We're back at the hue circle. Let's shuffle this hue circle first. So I'll say shuffle of values array. So it's now completely shuffled. Let me clear the console. I'll create the sorter class of that bubble sort. I'll create a sorter variable of that bubble sort. I'll say variable of that bubble sort. I'll first initialize this by calling the init sort. And finally, I'll call the do sort function. You can now see the sorting happening and you can see what it is doing currently, right? Now this is incomplete without a little bit of sound, right? Because all sorting visualizations are accompanied with sound. So let's add some sound to it and we'll see how it goes. We'll start by creating an audio context variable and an init audio function. In this function, the audio context is initialized to the window.audio context, and for browsers where it is not available, we'll initialize it to the WebKit audio context value. I have a function here called playNode that takes in a frequency and a duration. This function will play a specific frequency for a particular duration. We'll create the audio oscillator using the audio context's create oscillator function. We'll set the oscillator type to sine and we'll also set a specific value. Next, we'll need to control the volume using the gain node like so. The gain node is connected to the audio context and the oscillator is connected to the gain node. The start function starts playing the oscillator node. And after a very specific timeout, we can call the oscillator.stop to stop playing that frequency. In this manner, that frequency will be played for that duration. Let's implement this into our sort and we'll see how our sorting visualization now sounds like. Alright, so now I have initialized the audio in the main load function and I have also refreshed the screen. Let's shuffle this, like we always do. So let's shuffle so that now my hue disk is completely randomized. I'm going to clear the console. Then we'll create the sorter like we always do. Next, we'll call the init sort and finally we will do the do sort. So you can now see that the visualization is complete. The frequency you're hearing is the value that is being sorted at that specific index. Let's do the quick sort now and let's compare it to the bubble sort. Alright, so let's quickly look at the quick sort algorithm. It's a divide and conquer algorithm and it works by selecting a pivot element from the array and partitioning the other elements into two sub arrays. Now on the right hand side of the pivot, let's take for example this randomized array. Now usually the pivot is taken as the last element, although technically speaking it can be any element from the array. So let's let's make it easier for ourselves, and let's take the last element out of the array. That becomes my pivot, and what I do is I create two more arrays. In one, I will have all of the items of the array that are less than the pivot element, and on the right I will have all of the elements that are greater than the pivot element. So that way I like partition them. Now for all of the remaining arrays also, I recursively do the same thing. So this is a divide and conquer, and that divide and conquer happens through recursion. So in our big array, it gets split into the small array. It's split like this, 1, 2, 3, 4, 5. 5 goes on the right because 4 is the pivot element. And then once again, this small array is also pivoted. And at the end, what you do is you join all of these elements. You will get the array in a sorted manner without even doing any swaps, for example. So your array would look like 1, 2, 3, 4, 5, 6, 7. So your end array would have all of the items sorted without you even swapping anything. So let's implement this in JavaScript and see how that goes. We'll create a class called quicksort. This will have a function called quicksort that takes in an array and a low index and high index as parameters. If the low index is less than high index, it means that the array is not yet sorted. We'll call a function here called partition, which we will shortly define, whose job it is to find the pivot elements such that the elements smaller than the pivot are on the left and the elements greater than the pivot are on the right. Once we have the pivot, we will divide and conquer using recursion by calling the quicksort 2 more times on the divided arrays by their pivot point. And finally, we'll call the quicksort from the doSort function. Here's the partition function. We'll first choose the pivot point to the rightmost element of the array. We'll initialize the pointer for the greater element. We'll traverse through all the elements from low to high and compare each element with the pivot. If the element is smaller than that pivot, then we will swap it with a greater element pointed by I. Finally, we'll swap the pivot element with the greater element specified by I. We'll put a sleep here and return the position from which the partition was done. Alright, I've added the sounds to the quicksort as well in the partition function. And I'm going to now shuffle it first, as per usual. Say shuffle of values array. So now it is all shuffled. Let me clear the console. And next, let me create an instance of the quicksort class first. And I'll have to first initialize it. And then I'll have to say sort. You weren't expecting that now, were you? All right, so I'm going to do a few more modifications to this page so that the sorting is now appearing in a drop down so that I can choose what sorting to be applied. And I'm also going to be implementing a few other sorts, and then I'll demo all of the other sorts that I've implemented, and then we'll call it goodbye. All right, so I have made all of the modifications to this page, right? First things first, I have a drop down over here that shows all of the available sort functions. I have 3 different buttons over here. One is to sort, to shuffle, and then to mute if you don't want to listen to it. I've also added some text over here that basically shows how many loops how many loops we have done, how many swaps we have performed, and how much is the time elapsed. So it basically shows you how fast or how slow something is. Let's start with the bubble sort and let's see how slow or fast that is. I'll shuffle and then I'll sort. Good, right? Now remember, the bubble sort is generally not implemented anywhere. This is a good sorting to begin your learning with, but nobody implements it anywhere in the real world. Let's look at quicksort. We've already seen this, but just look at how fast this is. Oh boy, it's done even before we could say hello. Okay, now let's look at the counting sort. All right, so this is another sort that we've not sort of explained in this episode, but you can look elsewhere. It's a very easy sort to implement. And although it looks like the bubble sort, you can see that it's actually not, because the way it sorts the array is different from the bubble sort. The counting sort also doesn't do any variable swapping, so that way it has that edge over bubble sort. Let's shuffle it. Now let's look at the insertion sort. And once again, it's a little bit different than the bubble sort, even though it looks as slow as it is. The number of loops and swaps that it goes through is also a little bit lesser than the bubble sort, of course. And finally, let's shuffle it once again and let's look at the bucket sort. Now this also has the potential to surprise you, but we'll see. Now, if you want me to explain how each one of these sorts do work, please let me know in the comments. I'll have separate smaller episodes for each one of these sorts. Just only goes into explaining how these sort functions work. You can leave a like if you want or don't want. All right. So that's about all we had for this week. Do join us back again next week, and we'll do something interesting. Bye.